Let's work one final example of a problem that we would see that would have the direction solved by quadratic formula. And this is going to have a different answer type, so that's why I've got 3 different examples, because there's 3 different ways that you might see your answer on a problem like this. So first of all, we need to make sure it's in the form ax squared plus bx plus c equals 0, and it is. And so now we can pick out our a, b, and c. So a on this one is what we're multiplying by x squared. That's a 2. It's our coefficient of x squared. B is the coefficient of x. That means the number you're multiplying by x. That's a positive 8. And c is going to be the constant at the end. And so that's a 22 in this problem. Always a good idea to write out the formula again just to make sure you're getting that memorized. So I've already written that out here. So now we'll plug in our variables. So we have negative 8 plus or minus the square root of b squared, which is 8 squared, minus 4 times a, which is 2, times c, which is 22. Let's bring our radical over long enough. All over 2 times a, which was 2. And so now we need to simplify what's on the inside here. And so that's going to be negative 8 plus or minus the square root of 64 minus 176. And so let's put that in there, all over 4. And so now we need to simplify what's inside the radical. And that'll give us a negative 8 plus or minus the square root of negative 112, all over 4. But wait a minute, I thought we couldn't take the square root of a radical. Well, we can if we recognize that of a radical with a negative inside of it. When we have a negative inside of a radical and we're trying to take the square root, remember we just use the fact that we've come up with an imaginary number, which we use for the square root of negative 1. So I is equal to the square root of negative 1. So when we've got a negative inside of a radical, then we're going to replace that with I on the outside of the radical. Let me just rewrite that step. You don't have to write this step necessarily. You can go to the next one, but I'm just trying to emphasize a point. So the I is outside of the radical. Don't put it inside. Some people put it in front of the radical just to make sure that they don't accidentally keep it inside the radical. Technically that's not proper form, so I prefer to put it on the outside. So now I've been telling you that in class I would be showing you a different technique for, other than the factor tree, when we're trying to simplify the square root of 112, because it can be simplified. So you could use the factor tree like what we did in the last problem, but what I'm going to start doing in class uses less paper, so let's look at how we do that. We're just going to show an upside down division symbol, and we're going to show what we would factor out of here. So again, using our prime numbers, and we're going to start with the smallest one, 2. If 2 goes in here, and it will, since this is even, we will factor out a 2. So imagine yourself as kind of dividing upside down. So you could say 2, you can either use your calculator, which is easy enough, or you can say, well, 2 goes into 11 how many times? Well, it goes in there 5 times with 1 left over. Let me put the 1 in front of the next digit, which is a 2. 2 goes into 12 how many times? 6. Or you could use your calculator and say 112 divided by 2 is 56. Either one gets you there. And now from here, we can say, well, does 2 go in here? Well, yes, it does. 2 goes into there how many times? Well, you can either, if you know, it's 28. Or you can say, okay, 2 goes into 5 how many times? 2. And with 1 left over, put the 1 in front of the next digit. 2 goes into 16 how many times? 8 times. And now we're going to go one more. And so that would be... Okay, so we found that 2 goes into 56 28 times, and now will 2 go into 28? Yes, it will. So we're just going to keep going until we get down to a prime number. So 2 goes into 28, goes into 2, 1, well, it goes in there 14 times. Let's not make this complicated. Does 2 go into 14? Yes, it does. 2 goes in there 7 times. So 7 is prime, so now we've got this in a product of primes. And so even though it's written this way, it still means the same thing, and actually it kind of looks a little clearer. It's not all over the paper, it's just in one little spot. So 112 is equal to 2 times 2 times 2 times 2 times 7. So from here, since we were working with square root, we're going to circle groups of 2. Here's a group of 2, 2 2s. Here's a group of 2. Now, it doesn't always have to be the number 2, just these 2 examples happen to have 2. And here, I'm going to underline what's left over. So what I'm saying is, by looking at this now, we can say that the square root of 112 is equal to 2 times 2, it's anything we circled a group of, 2 times 2 times, and what's left on the inside is whatever we've underlined. And if there's more than one thing underlined, we would multiply them. And so the square root of 112 simplifies to 4 square root of 7. Now let's put that up here. So that would mean that we've got negative 8 plus or minus 4 square root of 7, that's taken the place of the square root of 112, with an I on the outside all over 4. Now recall in math we want to simplify if we can, so we're going to ask ourselves, is there something that goes into both of the terms in my numerator and the term in my denominator? Well, yes, there is. It's a 4. So let's factor out a 4, so that would be 4 times negative 2 plus or minus the square root of 7i all over 4. Again, we're going to cancel the like terms. When we cancel it, that doesn't leave anything in the denominator. And so that means we're just left with negative 2 plus or minus square root of 7i with that I on the outside. Recall that that's 2 different answers. On my math lab, you would have to write that as negative 2 plus square root of 7i and negative 2 minus square root of 7i, although they probably are just as happy with that I in front of the radical. And that would be inside of braces saying this is our set of answers. It's both these 2 answers.